This will be a video for the first section of Chapter 3, Mathematical Induction. This is the new proof method. The proof is basically stating if you can prove it for n plus 1, then you can prove it for, if you can prove something's true for n plus 1, you can prove it for anything. And so example statements, probably the best example statement that we have would be saying we have this p of n that is equal to 1 plus 2 plus 3, so on, all the way to n, and this is equal to n times n plus 1 over 2. So you're looking at this like, okay, how would we prove this? Well, there's 3 steps. Step 1 is show that it's true for p of 1. So what we can do is say that equals 1, and then that's the first term, so that's good, equals 1 times 1 plus 1 over 2 equals 1 times 2 over 2 equals 1. So we can say that it is true for 1. Then we just get to assume p of n is true. Then the last step is showing p of n plus 1 is true. And so, like, how do we prove that? It's quite simple. What we do is we get something that we want to show. I'll write that up here. We want to show that 1 plus 2 plus 3 plus so on plus n plus 1 is equal to, remember it was n times n plus 1 over 2. We can substitute the n plus 1 for all cases of n on the right side. You get n plus 1 times n plus 1 plus 1 all over 2. I want to show this. And this can be turned more simply into n squared plus 3n plus 2 all over 2. So left hand side we're going to have p of n, what we're starting with, which is our 1 plus 2 plus 3, so on. And on our right side we're going to have our n times n plus 1 over 2, which I'm going to rewrite as n squared plus n over 2. Now what we can do is we can add n plus 1 to both sides. So we can do p of n plus 1 is equal to n squared plus n over 2 plus n plus 1. So we say pn plus n plus 1 equals n squared plus n over 2. We can get a common denominator here, plus 2n plus 2 over 2. So we get p of n plus n plus 1 equals n squared plus 3n plus 2 all over 2. And we can rewrite pn as 1 plus 3 plus 3, so we have 1 plus 2 plus 3 plus all the way to n plus 1 equals n squared plus 3n plus 2 over 2, which we stated earlier is equivalent to n plus 1 times n plus 1 all over 2. And then we can say transitive property between these two, and then that's proof. That's basically just the gist of it. It's going to get more complicated than this, but you've basically followed the same general idea for all the proofs.